Expressions and equations. Number 7, solving equations with one variable. Our first learning target in this standard is I can solve linear equations with one variable that may require combining like terms and or using the distributive property. So the first thing we're going to do is define some words here. So I have 3 words we're going to look at right away: coefficient, constant, and variable. All of these 3 things make up an equation or an expression. So a coefficient is a numerical value before the variable. So numerical meaning a number of some sort of value before a variable. A constant is a number without a variable, so it's just a number or a number. And a variable is an unknown value represented by a letter. So the first thing I'm going to do is just going to start with the example here. Let's say we have 4x minus 7 equals 5. So my expression is 4x minus 7, and to make an equation, we put an equal sign, and this equals 5. So what we're going to look at is just looking at vocab. So the coefficient is the numerical value before it's the variable. So the only variable I see is x here, so the coefficient is 4. So the coefficient in this problem is 4. Next one, a constant is a number without a variable. Well, that's coefficient and variable. This is a number without a variable. So I have one constant, and then I look at the equal, and I have the second constant. So both this is 7 and 5. -7 and 5. And a variable is the unknown value, so we don't know what x equals, and it's represented by a letter. In this case, it's represented by the variable of x. So those are the parts of an equation or an expression. The 2 things that we're going to do mathematically, the 2 processes, are combining like terms, which is a process to simplify, which means to make an expression simpler. Instead of maybe 5 terms, we take it down to 2 terms by adding like terms together. And the other one we're going to look at is distributing property, a process to simplify an expression by multiplying a term or a constant to the terms in the parentheses. So let's look at a couple examples there for both of those. Let's look at combining like terms. So let's say we have 3x plus 5 minus 4x plus 10. Okay, combining like terms means we're going to look at the like terms. And some of you may have done this in the past, and you put boxes around each term. I'm going to go ahead and do that in case that's a visual you're used to. So I look at these 4 boxes, and I look at a like term. So a like term has to have the exact same variable, or it has to have the same constant, or just a constant. So in this case, I have 3x and I have -4x. So I'm going to add those together. So 3x plus a -4x. And then I have 5 plus 10. So when I take both of those and I simplify the expression by adding like terms, so 3x plus -4x is -1x. And 5 plus 10 is 15. So this new expression simplified, which means making it a smaller amount or less terms, is -1x plus 15. Distributive property. So we're going to multiply, notice the operation here, a term or constants to a term within the parentheses. So let's say we have 4 on the outside, -x minus 5. So we're going to multiply the constant, or the term outside, in this case it's a constant, to the terms inside. So we're going to take 4 times -x, which is -4x, and we're going to take 4 times -5, which is -20. So I did that, and I simplified it. Instead of a constant, a variable, well, actually this is a term because there's a coefficient of 1 there, -1, and then a constant, and I multiplied them to get a simpler term. The last thing we're going to look at is when we're actually solving these problems, the idea of an inverse. An inverse is an opposite effect or the reverse of. So when we're getting into these problems and I'm trying to get rid of +5, I'm going to do the inverse, or the opposite effect or the reverse of. So opposites are, if you have multiplication, you're going to divide. And if you have addition, you're going to subtract. So let's get into some of these problems so we can work on all that vocabulary we just looked at. So our first example we're going to look at is 5x plus 2 equals 32. So our goal when solving equations is to get the x alone. And so we're going to inverse or reverse the 5 and the adding of 2 so that we can get rid of those 2 and leave that x alone so we can figure out the inverse. We can figure out the value of the variable. So let's start here. And I always start with adding and subtracting, or the one that's not attached to the variable. So we're going to get rid of this constant here of adding 2, and the inverse would be to subtract 2. And notice you have to do it to both sides. It's not a one-sided thing, it's both sides. And I know some of you are used to having a line down the middle. If that makes sense to you, go for it. Because if you do it to one side, you must do it to the other side to keep that idea of equal. And I sometimes like to put the equal sign in the middle of there to remind myself, yes, if I do it to one side, I have to do it to the other side. And notice that since we did the inverse, it's going to cancel each other out. And we're going to get rid of that positive 2 or that plus 2 to get that x by itself even closer to that goal. So positive 2, negative 2, opposites of each other. So they cancel each other out. I'm just put a little x there. Bring down that 5x that's still there. Keep my equal sign since it's an equality. And 32 minus 2 is 30. So I'm going to reevaluate I have here. I have 5x equals 30. Well, if I look at 5x, or a coefficient in a term here, or a variable, the only invisible operation there is multiplication. So if I sneak a little multiplication sign in there, there is multiplication going on between the coefficient of 5 and the variable of x. So the inverse, or the opposite of multiplying by 5, is to divide by 5. And if you do it to one side, you must do it to the other side. And 5 divided by 5 mathematically is 1 little x, which is our goal to get by itself to start with. And then I go over here, I'm just going to solve. 30 divided by 5 is 6, and that is my final answer. Now, one important step, and I always say you should never miss any of these if you take time to check it. And a calculator is a marvelous tool because it does most of it for you, but we're just going to write it out. So to check it, you have to put it back in that variable, and we're going to put that x equals 6 back in for x. So instead of putting x there, we're going to put what the new value of x is, which is 6, because that was our unknown as x, and now we found it to be known as 6. So we're going to put it back up there. I'm just going to write the rest of the problem out. So we have 5 times our now known value is 6 plus 2 equals 32. Now I'm just going to simplify and solve to make sure my answer actually equals 32. So 5 times 6 is 30 plus that 2. So then we have 30 plus 2 is 32, and that's what it was supposed to equal. So I know and I can guarantee it's a correct answer. Example number 2. This time we're going to put 200 equals 50 plus x divided by 3. So our goal again is to get this little x to be by itself so we can have x equals a value. And that's what we're looking for, is that unknown x value. So again, we're going to always start with the number away or not attached to the x. So in this case is the 50. So to get rid of 50, we're going to take away 50. And we got to do it on both sides. Again, I'll put my line down here if that helps. So if I do take away 50 from the right side, I must take away 50 from the left side. And again, if you like that equal sign to keep track, that you make sure you're doing things to both sides of the equations to keep it equal. I have 200 minus 50, which is 150. And now that equals, because these cancel out, we have x divided by 3. And I just kind of gave it away. I said x divided by 3. Well, the inverse, the opposite to get rid of, to reverse, is to multiply by 3. So I have 150 times 3 on the left side, which is 450, and that equals, well, those two are going to cross each other out since they're inverses, so we're left with x equals 450. Quick check here. Go back to the original, enter the values of the unknown. So since x is equal to 450, I plugged 450 in for the x, and now we're just going to solve to make sure it really equals 200. So 450 divided by 3 is 150. Look at my new problem here, my expression here. I can combine those like terms since they're both constants. I get 200, and it's supposed to equal 200, and I check mark yes, I know, and I can guarantee that's the right answer. Let's go to example number 3. This time we're going to look with some fractions, and don't let fractions bug you. If you really, really dislike fractions, you can always change this into a decimal by taking 7 divided by 10 or 3 divided by 10. So we look at this and we see we have a m, which is what we're going to try to get by ourselves. We have a 50 that's attached, and we have 3/10 that's attached. So we're going to get rid of that 3/10, and to get rid of that, we're going to subtract 3/10 from both sides. Okay, notice I still have equality. I'll put my line down the corner here. And if you have a great graphing calculator, or you have a scientific calculator that loves fractions, you can do it. Or otherwise, you can just think through it. 7/10 minus 3/10 would leave you with 4/10. And now that's equal to m divided by 50, because those are inverses of each other, so they cancel each other out. It's like thinking of -3 and 3. Well, if you add those two together or put them together, they would equal 0. So it's the same thing. We're just canceling out because they are inverses, and so they would equal 0 if you add them together. We look at this again. We notice it's m divided by 50. The inverse would be to multiply times 50. So 50 multiplying and then divide leaves you with just the m. That's my goal. And I come over here, 50 times 4/10, and I quickly put that in my calculator or mentally math, and I notice that is 20. So the unknown value of m is now 20. Now go ahead and check it quick. So 7/10 is supposed to equal 3/10 plus 20/50. So it's already kind of a problem here. I'm going to simplify this into a fraction here. And since they both have zeros, I can cross that out. So now I have 2/10. And if you remember, if you're adding fractions, you have to have the same same denominator. So 2/5 is the same thing as 4/10. Look at my problem. I can simplify it by actually adding that. So I get 7/10, because 3 times 4 equals 7, and 10 times is 10. So it keeps the same denominator, and notice that 7/10 equals 7/10. Again, if the fraction work makes you anxious, go ahead and put them into decimals by taking the numerator divided by the denominator. New problem? We have 44 is equivalent to x plus 3 times x plus 2. So if I look at this, I have a constant, a variable, a constant. Okay, inside a parenthesis, I have a variable and a constant. But since this is a parentheses, I know my PEMDAS, PEMDAS. The first thing is to get rid of parentheses. And that operation, remember, to simplify this, is we're going to distribute. So I'm going to technically distribute the positive 3 to the x by multiplication and to the 2 by multiplication. So 3 times x is 3x. 3 times 2 is 6. And now I'm just going to drop down everything I see. And I know that's a positive 3x. Drop down the x. I have 44. And now Distributive property is done. It did its duty. It simplified my expression and got rid of the parentheses. Now I'm going to look at this and I notice there's still 3 terms. The question is, can I combine like terms to make this easier on myself? Well, I look at my 3 boxes and I notice I have a constant of 6, I have 3x, and I have an x. Well, the 2 alike terms are your x's. So 1x and 3 x's, because technically there is a 1 there, is 4x, and the constant of 6 is just going to hang out because there's nothing to combine it to. In other words, add it to. I'm going to pull down my 44, and I'm going to go to work here. I need x by itself, so I'm going to think of that inverse, that reverse operation. So since this is adding 6, the inverse would be subtracting 6 from both sides. I'll put my line down here. I'm going to keep that equal by doing the same thing to both sides. I end up with 4x, a positive 6 minus 6, or a positive 6 and a negative 6. Since they're inverses, they cross each other out. I'm going to pull down 44 minus 6 is 38. And I'm almost done with my equation because I only have one more number that's bugging the x, which is a 4. Again, remember 4x is multiplication, 4 times x. The inverse would be to divide by 4. And this becomes 1x because 4 divided by 4 is 1x, and 38 divided by 4 is 9.5. So the value of x, or my unknown value of x, was 9.5. Quick check. Go back and put it into your equation. So instead of x now, we know the value is hopefully 9.5. Add 3, take that times 9.5, add 2, and go ahead and simplify here. Again, you can put this all in your calculator at one time. I like to work my mental math. So I have adding 3, 9.5 plus 2 is 11.5. And now I'm going to multiply because that's my next step. Since there's no exponents, 3 times 11.5 is 34.5. Bring down the 9.5, and from here I just simplify like terms, which means add the 2 constants that are left, and 9.5 plus 34.5 equals 44. I can guarantee that x is equal to 9.5 because it works as a check. Last example today, let's go with negative 5 times x minus 7.25 minus 1.25 equals 0. So goal again is to get x by itself. And this is going to take a little bit more work because notice there are 2 x's on the same side of the equation. I'll put my little yellow line down to keep it separated. So PEMDAS, exponents first, means I need to do the distributive property. So I'm going to take 5 times x, and I'm going to get negative 5x, and then take negative 5 times, as this is a negative 7.25. So going back into my math, negative times a negative equals a positive. So I end up with a positive 36.25. And now I'm going to pull down my term I haven't used yet, and that still is equivalent to 0. So I notice there's 3 terms, which probably means I can combine like terms. I'm going to box this. You don't have to. For some people, this is a visual. I look at my box. I have a constant. I have a variable. I have a variable, which means I can put my 2 variables together. So negative 5x and a negative 1.25 is going to equal a negative 6.25x. The constant's just hanging out because there's nothing to do with it or to combine together. And now we're going to start our inverse operations to get to x by itself. And notice now, since we combined the like terms above to get this negative 6.25x, now I only have one set of x. So I just have to deal with getting that by itself. So the first thing, remember, is to do the operation that's not attached to the x. So since it's adding 36.25, to inverse that, or to make opposite, so the opposite of addition is subtraction. So we're going to subtract negative 36.25, or And we're going to put our equal sign there to make sure we keep equivalence. So I bring this down. I now have negative 625x. These are inverses of each other. They cancel each other out, which is nice. So now I don't have to look at that extra constant. Revalue it again. Here's my x. Now bothering it is negative 6.25. So to inverse of multiplication, remember that's that hidden operation, is that we're going to divide. I'm going to relook at this. I notice that I have negative 6.25 divided by negative 0.625, which equals x. And I'm going to throw that in my calculator, and the value of x equals 5.8. So our unknown value of x equals 5.8. Now we can do the fun part. We get to check this one. So I'm going to put it back into the original equation, except for this time, instead of putting an x, I'm going to substitute 5.8 in there. So it's negative 5 times, it was an x, but we're going to put 5.8 since that's our new value, minus 7.25, and then minus 1.25 times, now the value of x is 5.8, and this is all going to equal hopefully 0. So parentheses first, I'm going to subtract that. I get negative 1.75, and then I'm going to multiply this, which is 7.25, still all supposed to equal 0. I look at it, negative 5 times negative 1.45 is negative 7.25. I'm sorry, that is a positive, because a negative times a negative is a positive. I'm going to subtract that from 7.25, and I'm going to notice that equals 0 now. So 0 equals 0. And I have proved that my x really does equal 5.8.